Okay, we're going to now look at some more problems involving the constant acceleration formulas. So, let's start. Okay, just to remind you about those formulas, the three formulas we're going to be referring to are V equals U plus AT, V squared equals U squared plus 2AX, and X equals UT plus 1/2 AT squared. Okay, now the first problem we're going to look at is one where we've got a person throwing an object up into the air. So let's draw a picture. So we have a person, there's the ground here, and our person is standing here, and they're going to throw a rock in the upward direction, and they're going to throw it up at a speed of 15 meters per second. And the question we're going to ask is, there's two parts to this question. Question part 1, or part A of this question, is how long is the ball in the air for, or the rock in the air for? So for what length of time is the rock airborne, and part B of the question is what is the maximum height achieved by the rock. And in future, we will refer to that as H max, the maximum height achieved. Okay, so all we've got so far is a person, they're throwing up a rock, and it's 15 meters per second they're throwing it up at. One thing we do know, because this is taking place on the planet Earth, and it's near the surface of the Earth, we know that the value of G, the acceleration due to gravity, is 9.8 meters per second squared. And that, of course, is acting down. So we know the acceleration is acting down, and it equals G, which equals 9.8 meters per second squared. So let's see if we can actually just intuitively think what's going to happen here. The ball is going to be thrown up, and it's going to be thrown straight up. It'll reach some maximum height, some position, and then will fall back to the earth again. So at this point here, that's what we call H max. Now if you think about that, if this ball is going straight up, moving up and slowing down, at some point for a small instant of time, it will actually be at rest. So the moment it reaches its maximum height, it is for that instant at rest. Its velocity is 0. Then it will start to speed up again as it falls back to the earth. So one thing we always need to bear in mind, if we have to find the maximum height, if something's thrown straight up, that will always be when the velocity at that instant is 0. So at maximum height, the upward velocity, the vertical velocity of the ball will be 0, or whatever the object is. In this case, it's a rock. I apologise. So that's really all the information we need to know to solve these problems. So have a go at solving it yourself. Pause the program, the video, and then once you've had a go, play the video and check your answers. Okay, welcome back. And now we're going to go through this problem. The first part of the problem was, what is the length of time that it's in the air for? So the ball has been launched, reaches the maximum height, and then comes back to the earth. So the ball is now returned to this position. So what do we know about it? Well, let's summarise the information. We know that the initial velocity, in problem part A, we know that the initial velocity was, what have I forgotten? I've forgotten to assign a direction. So because the initial direction is up, I'm going to call up positive and therefore down is negative. So the initial velocity is positive 15 metres per second. We know that the acceleration due to gravity is acting in the negative direction, so it's actually equal to negative 9.8 metres per second squared. And the only other thing we know is that when the ball returns to its original spot, it's as if it hasn't gone anywhere. In other words, its displacement or change in position is 0. It's exactly returned to where it started from. So its position, its change in position compared to where it started is 0. So we know that its displacement or change in position is 0. So x, which equals the displacement of the ball, the rock, equals, in this case, 0. So the question is, we wish to work out the length of time of duration. So we wish to work out t. What is the time it's in the air for? So we're looking for a formula that connects u, a, x, and t. U, a, t, and v is the first one. U, a, v, and x. Well, that's not good to us. That's really not necessarily helpful to us either, because it also has a v and it doesn't have a t in there. This third one has a u, has a, and it has t as the unknown, and x. The problem here, of course, is that we're trying to find t, and t occurs in two different places, which means to solve it we would have to use the quadratic formula. Now, those of you who are mathematically able can go ahead and do it that way. Those of you who don't like using the quadratic formula or factorising or completing the square to solve that problem, you can do it quite easily by doing two steps. Remember, we said that we know u, a, and x. So we know u, a, and x. So we can use this formula to work out v, the velocity it was moving at. And then once we've got v, we can then use this equation up here to work out t. So for the rest of us, it will be a two-step problem. So let's go ahead and do that. So we're going to use v squared equals u squared plus 2ax to begin with. And let's plug our numbers in. So it's going to be u squared, which is 15 squared, plus 2 times negative 9.8 times 0. X is 0. Check that out. So that makes our calculation quite, that's a 0 by the way. So that becomes quite easy to calculate now, because all of that is multiplied by 0, so that just cancels out to nothing. So it's just left with 15 squared. So v squared equals 15 squared. That means that v must equal 15. Well, actually, it's plus or minus 15. Remember, we now have to decide which is the correct sign. Well, when the ball was travelling back to the Earth, it was moving in that direction. And that is the negative direction. So the answer we need to take is the negative answer. So for us, v equals negative 15 meters per second. The next step is to now use V and the other data to work out T. So we're now going to use this formula, V equals U plus AT. We're trying to find T, remember, and so we need to rearrange this. So V minus U equals AT, and therefore V minus U all over A equals T. So T therefore equals V, which is negative 15, minus U, which is 15, divided by the acceleration, which is negative 9.8. So negative 15 times negative 15, negative 15 minus 15 is negative 30 over negative 9.8. So that's just going to be a little bit over 3. We'll just do a quick calculation here. 30 divided by 9.8 is 3.06, or roughly 3.06. So that's telling us that the ball was in the air for just a fraction over 3 seconds. Okay, so looking at part B now, we now get a new layer happening. We'll hide that layer. Hide that layer. Anyway, we'll hide this. We'll hide that layer. Okay, part B was to work out the maximum height. So, just from memory again, the person threw the ball up with an initial speed of 15 meters per second, and we know that when the ball gets to its maximum height, its velocity will be 0. We also know that for the life of this journey, the acceleration is negative 9.8 meters per second squared. So we now have 3 pieces of information. We know that the final velocity is 0, taking into account that the final velocity we're talking about in this scenario is when it reaches its maximum height. The initial velocity is 15 meters per second and the acceleration is negative 9.8. Remembering that down is negative and up is positive. So we wish to work out h max. So we want to work out the height, which is x. So we know A equals negative 9.8 meters per second squared. We know that U equals positive 15 meters per second. And we know that V equals 0. We're trying to find x. So here we can use the formula, the same formula we did in the previous problem. We can use V squared equals U squared plus 2AX. And we wish to rearrange this so that x is the subject, because that's what we're trying to find. So we've got V squared minus U squared equals 2AX. And therefore, dividing both sides by 2a, we've got V squared minus U squared over 2a equals x. So let's plug our numbers in. I'm just going to move over here. So therefore, x is equal to V squared, which is 0, so it's 0 squared minus U squared. U is 15, so it's minus 15 squared over 2 times negative 9.8. 15 squared is 225, so it's going to be 0 minus 225 divided by 2 times 9.8, well, that's negative 19.6. So our final solution is actually, it's going to be negative 225 divided by negative 19.6. The two negatives cancel each other out, so it's actually 225 over 19.6. And if we work that out, we see that the answer is about 11.48. So 11.48 meters. So that's telling us that this rock, when it was thrown, reached a maximum height. Its maximum height that was reached was 11.48 meters above the ground. And that makes sense too, because we got, notice we've got a positive value here, and we expect the maximum height to be a positive value because up is positive. So everything works out. So there's our first example. Go to the next video on constant acceleration problems, number 2, to look at our next example. Thank you.